Welcome, everybody. I think we can start. It's 2 minutes. I can see already 123 participants. So, so these are the first lectures of the academic training in 21. You know that these series were postponed to this year for COVID reasons. So first, I would like to thank you for your patience and thanks to the speakers for their flexibility. As you know, at CERN, we are continuously analyzing data from scientific fields, but also for technological fields. And even nowadays, students in high schools, universities, are analyzing data. Nowadays, it's very easy to get data, but we need to understand it. So CERN offers a set of tools or a complete architecture that allows an easy and flexible data analytics. Even there is a project called Up to You that is in Science Box. They will say about this, that is offering this architecture for outside CERN. So this first lecture is going to be presented by 3 speakers, and I will handle the questions at the end. There will be 2 options. First will be just writing your questions via chat, and then I will read them, and then the speakers will reply to you. And the second options will be that you raise your hand with the Zoom. I hope you are familiar, and then I will give you the turn. And then, of course, the speakers will answer your questions. But first, before starting, I just want to introduce the speakers. So from the Software for Experiments team, we have Enric, who is the interface of the physics experiments and is in charge of the software releases and ensures that the tool is friendly for the end users. Then from the database team, from IT department, we have Prasanth, who takes care of the computational tools that will allow high performance during the data analysis by using Spark, and even he's going to talk about the GPUs. Also, at the end, we have Diogo, who ensures the data reliability and and easy access, also offering sync and sharing in between different data sources and teams. Everything from the storage team, where EOS and on top Thermox is involved. So join me to welcome these 3 speakers, Diogo, Prasanth, and Enric. So I will turn off my camera, and then the floor is for you, Diogo.
Thank you. You can see my screen, correct? And you can hear me.
Perfectly fine.
Okay. Thank you, Maria. Welcome, everyone, to the SWAN academic training. My name is Diogo. As it was mentioned, today is dedicated to know the basics of the service. And I would like to start by explaining what SWAN is. SWAN is an acronym for Service for Web-Based Analysis. It's based on the popular Jupyter notebooks. So we also say that it's CERN's notebook service. In case you don't know, notebooks are a format that allow mixing of text, images, kind of like a normal document, but it can also include in the middle code. And the interesting part is that you can run that code and then still have the output of that running the code in the middle of your notebook. And this output can even be, for example, dynamic. And you can see here in the slides a picture of a notebook. It's usually used for interactive analysis, but above all, we think this is a pretty efficient way of telling your full story, organizing or combining your work in a single and really easy to read file. But SWAN is not only that. What makes it different from any other Jupyter installation, like for example, the ones that you might have in your laptops, are the integrations that were done. In particular, the integrations of the CERN services. If we looked at the slides, of course, you would expect that the core and UI is Jupyter and Jupyter Hub, but then we have integrations of, for example, in the analysis platforms, we have Root, we have R, we have Octave, Python. We also have tools like TensorFlow. On the computational side, we have access to the Spark clusters at CERN, to Apache Hadoop. All of the software that you have in the service comes from CVMFS, which is also the way that the experiments at CERN expose their software. Then on the storage, unlike some services that might have volatile storage in SWAN, your home directory is CERNbox, so all of your files are available. You also have access to EOS, so you have access to your experiments data, and all of this runs in the CERN IT infrastructure. So in conclusion, it's a fully fledged, pre-configured and powerful analysis ecosystem. And more importantly, it's easy to use and especially easy to start using, which is something that our users really like, and we believe is one of our strongest points. These are the people who run the service. We are 8 people from the storage and databases groups in IT, and also the software for experiments group in EP. We all work in this project part-time, and today you will have the opportunity to see one representative from one of these groups. One last thing before going to the real service, I want to explain how it works under the hood. Of course, you don't need to understand everything or remember everything, but this still might give you some clues and help you understand and diagnose some of the problems that you might face. And the first thing that happens when you arrive to the service is that you'll be redirected to the CERN SSO, where you'll be able to authenticate. After that, the SSO will return you back to the service, and you will land in the portal, which is called Jupyter Hub. And this is where you can start your session. Of course, you can pick some configurations, as you'll see, but you'll have a button, and very easily it will start a session for you. And this session runs as a Docker container, where inside you have Jupyter installed, and you also have CVMFS and EOS mounted. So this means that you'll be isolated from other users, but more importantly, this also means that the resources are limited, because we want to allow a good experience for everyone. You can tinker a bit with, we have some options for the resources, but be aware that they are being limited. So it might happen that, for example, your notebook crashes due to lack of resources. Another thing that you might also have seen is that you go to swan.cern.ch, and then when you return to this, you go to the login, and when you return, you will land in SWAN 001, SWAN 002, etc. Currently, we have until 006. And this is because we have individual servers which we expose to our users. So if something is not working, it might be affecting only one node, and so you might try to switch to a different one to see if you also see the problems. But of course, we recommend that you always go to swan.cern.ch instead of going directly to a machine, because this way you are guaranteed that you will go to a machine that is currently in service, because from time to time, we might take a machine to do some maintenance. And also, this will change. We are starting soon the beta testing program of our new platform based in Kubernetes. So what is important for you to know is that you will have a single URL. It will be just swan.cern.ch. Of course, in the background, we will still have multiple servers, of course, but this will be hidden from you, and you will be assigned automatically to these machines every time that you try to start a session. But let's start with what you see once you access the service. You already know the URL, swan.cern.ch. That's how you access the service. But you also need to know that there are a few requirements. The first one is that you need a primary or secondary account. We do not support external accounts. This is for security reasons, because SWAN grants you access to the CERN network and to the CERN infrastructure. So we really need to be careful with whom we let in. And also, besides being for security reasons, you need a CERN box space, and to have one, you also need a primary and secondary account. So we are aligned on this. And you know that CERN box is SWAN's home directory, so you will have to have access the CERN box web UI at least once, because otherwise you don't have the storage space created for you, and you won't be able to access SWAN. Then optionally, if you need access to Spark, you will have to request authorization to use it, but my colleague Prasanth will talk about this in a bit. Right before I show you the UI, just a few more points. The first thing that you'll see once you land in SWAN is the options menu. This allows you to configure your session, but don't be afraid if you don't know what these options are, because the default values are usually the way to go. You can just click in start a session and that's it. But if you want a bit more to configure a bit more your environment, you can, for example, for software, you can pick a different LCG release. The LCG releases are basically a way of us grouping packages together to ensure that they work correctly with each other. And we also pin specific versions. So if you want to see, for example, what are the packages that are available on each stack, or you want to see their versions, you can go to lcginfo.cern.ch and you have there all the info. And if you use these stacks before, for example, in LX Plus, you know that this configures all of your environment, and it does that by sourcing a bash script. And this is exactly the same thing that we do as well. Then, of course, you can choose the system and the compiler, but currently we only support CC7, and the compiler will depend on the software stack. If, for example, you want to personalize your environment even more, for example, you want to replace some environment variable or switch something that adds some extra configuration, or replace something that the LCG usually sets and you don't want, you can do that by using an environment script. What you need to do is create a bash script, put it in your CERN box, and then you just need to put here the path in this environment script, and we will load right after loading the LCG stack. And then the last two things that you have here, or the last three things, are the resources that you have. You have also the possibility to choose if you want to connect to a specific Spark cluster or not. And the last thing is this option, which is called always start with this configuration. So basically, if you want to just go to swan.cern.ch and to immediately jump in your files and your notebooks without having to set the configuration again, you click here and it will always start with the configuration that you just selected. One last thing about the LCG releases. These are managed by the librarians in EP, and this is done in coordination with representatives from the experiments and some other groups. But for example, if you think some package would be relevant for a large community of users, you can still do a request to install these packages. Another thing is that we cache the recommended stacks. So for example, if you need some older version of a package, you can choose an older version or an older stack that has it, but be aware that this might take a bit more time to start. And then we also have bleeding edge stacks. These usually have all the latest versions of software, and these are the versions that will come with the next LCG release. So they are in a testing mode. So be aware, these might be unstable and might not work. But now let me switch to my browser and I'll go to swan.cern.ch. And as you can see, I was redirected to the CERN SSO. This is the new one, the new SSO that has been, that is replacing the old one. And you can see all the options that I have. I can choose from the list, but as I said, usually what you want is to just start with the default configuration, and that's what I'm doing here. While this starts, it's usually pretty quick. It's already started, but just some extra remarks. Once you start, you will see that CERN is your home. This means that all of your files are available, but for example, you know that you can already access them in your computer, for example, using the sync clients. You know that you can access your files via LX Plus or some other system that has EOS configured. And you can think of SWAN as another place in the many possible where you can access your files and your data. And you can even work across all of these environments. We have some users, for example, that are developing their scripts in their local laptop. This is synchronized with CERN, and then they just open the SWAN in their browser and run the scripts and let them run to do some analysis. So this is a possibility. But as soon as you start the service, as you'll see, you do not see all of your files at the first glance. You only see projects. We came up with this projects concept to organize your work. So imagine that you have notebooks, images, data sets, etc. You should have all of them inside a single project. And we consider this the single unit of sharing. So if you want to share your work with someone else, you'll be able to do it with the projects, and all of these files should be inside, and the projects should be self-contained. For now, a project is just a project that lives here inside this swan_projects folder, and it contains this .swan project file inside. So if, for example, you have some folder and you want to convert it to a project, just touch .swan project file inside, and it will be converted to a project. We are planning to add some extra functionality to this little file, for example, to simplify the software integration. But for now, this is just it. So let me get back to my browser. Let me close my presentation. 1 second, and move things around. So I am in SWAN, and the first thing that you want to do is to create a project. And there are 3 ways of doing it. The first one is that you might have seen already. There are some GitHub repos, for example, or GitLab repos that have a button that says Open in SWAN. You can click it, and the project will be automatically downloaded and created. You can also click in the download button here, and this will allow you to pass a URL of a GitHub or GitLab repo, and it will also download it and convert it into a project. And in this case, it also downloads submodules. Or the easier way, especially if you're starting from scratch, you just click plus. You can type some name, or you can leave it empty, and that's it. We have our first project. Really easy. Then, now that I have a project, what can I do? I can, if I already have files, I might have synchronized them with CERN, or I can just come here and click the upload button and upload these files directly from my computer. I can come here to the plus button, and I can create text files, whatever files you want to create. I can create folders, or I can create notebooks. And in SWAN, we have 4 options. We have Octave, Python. It depends on the stack. We have stacks with Python 3 and others with Python 2. You can choose. We have R, and we have root C++. This means that the notebooks that you're creating will be on this language, and you can program in that language. And in Jupyter terms, this means that I have 4 available kernels. Each of these is a kernel. This is the Python 3 kernel, for example. So let me create one. And it will open in a minute. This is already being saved in my CERN as well, so I could already start opening it from my local computer. Let me change, for example, the name. And voila. I have my, my notebook. And inside you might already seen that I have these rectangles. These rectangles are called cells, and this is where you can put your content. And since I created a Python notebook, this means that I can write Python code, very simple in my case. The interesting thing that you notice is that when I execute the code, the output will appear right below the cell, and this can even be dynamic. In the Python notebooks, I can also run bash commands. For example, I need to prepend this exclamation mark, but for example, I can run this command and it will run as well. Or, as I said, you can have texts and images, so I can write Markdown, like so. And if I execute it, it will fail. This is because by default, the cells expect code, but you have different types of cells, and I can change, for example, this for Markdown. But one second to look at these options. So you have basically three types of cell, which is code, Markdown, and raw for when converting with NB converts. The heading is here, but it's deprecated and it won't do anything, as you see when you try to use it. So let me convert this to Markdown, and it's here. I have my text right in the middle of my code. And you probably also noticed that I've been running my cells just with my keyboard. This is because we have keyboard shortcuts. Sorry. The most important to me is Shift Enter, because this allows me to run the cell that is selected. But you can see there are other possibilities. You can see here, for example, Command Save. This depends on the operating system. I'm in Mac OS, so this is targeted to my system, but you have here other options. And another thing that might happen, for example, if you are new to programming and you're trying to write your piece of code and you just did a mistake and the thing is looping, you can come to the kernel and interrupt it. Or if you just want to clean everything and start fresh, you can, for example, restart and clear. So this will be erasing completely everything that you've done, and will start from, I mean, not the content of the notebooks, but the execution that you did. So for example, then if you want to continue running, you'll have to run all the cells again, but then you have a button that allows you to do this easily. Another important thing that you need to have attention to is the saving status. You can see here, for example, that I have unsaved changes. Jupyter saves the notebooks from time to time, so it has autosave. But this, for example, might not have happen if your SSO cookie has expired, for example. This won't be possible because then you won't be able to communicate with the server because you don't have a valid session anymore. The UI should warn you about this if you try to close it, but please don't forget to click the save button. And when you do, you will have some information. Usually on the right, if there was any error, you will see a warning here. Here on the top, you can see that it has been saved, and you can also see that it created a version or a checkpoint, as it's called. So we are using use versioning under the hood. So you could come here, for example, to the file, and you could see that this created a checkpoint. And you can even see this from the CERN box interface as well. So imagine, for example, that I was editing my notebook, I did some mistake that I want to revert. I can just come to here, revert to checkpoint. This will revert the changes, and everything is fine again. Another thing that you need to be aware is that you should only have one window per notebook. Otherwise, what happens is that, imagine that you are editing two notebooks into separate windows. You edit in one, you save, you go to the other window, and what will happen is that you'll see a notification. And this notification will tell you that the file has changed in the disk, and it gives you two options. The first one is, I want to keep the content that I have in my window, And if you click that, you'll erase the content that you have in the disk. The other one is I want to keep the content that I have on disk. In this case, disk is EOS. So if you click that one, it will replace the content that you have on the screen. So either way, this will override data. So be very aware that there's this limitation in the Jupyter interface. Then for software, as you know, we said that you have the LCG stack, so you have a lot of software that comes from them. This comes from CVMFS. I can show you that. For example, if I run this, I can see that a lot of paths were added to the Python path. So you can pick software comes from all of these places and they live in CVMFS inside the LCG release. And as I said, if you want to install some extra package for a big community, you can ask this and you can put a request for the librarians. But you can also install packages in your CERN box and use them. We have a terminal prompt in SWAN, as I will show in a bit, but I also show you that I can run bash commands from here. So let me try, for example, to pip install some package. And this will run and it will install in CERNbox. And it will install in CERNbox because I put --user. If you don't put this, since this has been configured with the LCG stack, what happens is that people will try to install it in CVMFS. But CVMFS is a read-only file system, so you cannot do it. So you really need to put --user, and this will install inside your local, in your home folder. And so now I can use the package. So, and you can see that this is being loaded from my home directory. This actually worked because I have my home directory in this .local bin Python 3.7 side packages in the Python path. It might happen that you don't have it, so you might need to add it, but then this will work without any problems. But if you want more detail, I can show you that we have in SWAN a help menu that explains you everything about the service. So basically what we're saying here today, it's in more detail here in this help panel that you can see. And one of the topics is how to install packages in CERNbox. You have here all the instructions, and currently you can do this for Python and for R as well. So I have this wonderful notebook with a lot of interesting content. What should I do next? I might want to share this with my colleagues. So what I can do is I have here the share button that I can click, and just like in CERNbox, I can start typing for a different user. It will autocomplete with the name. You can search by name, and then I just click share. This got an error, but there's no problem because you click again and it has worked. So now, for example, I can go back to my files view. I also have the option to edit the share from here. One thing that I should mention is that, as I said before, the unit of sharing is the project. So you cannot share individual notebook files. So as you can see here, I'm sharing my project, which is called project. But I cannot share individual things inside because this way it will be self-contained with anything else. Another thing to notice is that we realized recently that CERNbox is returning the UID of the user instead of the username. This is a bug. This will be fixed very soon, so don't worry. But basically what you can do from here is that you can look for other people. You can share with them, you can delete individual users. So you just keep adding or deleting users, click update, and the share will be updated, or you can just click to stop altogether. Sorry for these errors. We're having some internet connections with CERN. I don't know if you are aware, but this is a problem that is ongoing. Then, okay, I shared with someone, but I might also have someone sharing things with me. So I can just go here to the Share tab, and I can see here all the projects that have been shared with me, and I can go inside them and see the content. But notice that this project has a README file, and this usually is explaining explains what this project is about, some recommendations or some requirements on software side, for example. And this README will appear right below the files list. And the interesting thing is that, for example, you can put some instructions here, and you can even put links to the notebooks. For example, I have this geometry visualization notebook that is linked right here from the README, and I can click it, and it will open the notebook as if I clicked in the files list. So this might be helpful for explaining people that don't really know which one they should open first, and that kind of situation. And then, since this has been shared with me, I can open this file, but this file is read-only. You cannot edit files that have been shared with you. Then you will see.
Just one comment we got. If you could zoom in a little bit. Yeah.
Okay.
Yeah, someone requested it to see.
Okay, so you cannot, there's this icon here, so you cannot, it tells you that this notebook is read-only. So every change that you do, it means that they won't be saved back to EOS. And another thing that you might have seen is that I have opened this notebook. There's a very big space here. This was supposed to be some output of this code, but I cannot see it. This is because when you open a foreign notebook, they are not trusted by default. This is done to avoid that code that you haven't given permission runs in your browser, and it might be malicious, of course. So this way, the notebook is not trusted, so you won't be able to see and execute the outputs. Of course, you can execute the cells, all of them, and then you'll get everything, all the outputs, because then it would be yourself doing the execution. So of course you should trust yourself that you only run things that you understand. Or you can just click here, not trusted, and this will ask you if you want to trust a notebook. I click yes, and the file reloads, and now we have the output here. And as I said, the output of cells can be dynamic, can be interactive. And the cool thing is that when you share, this is also the case. You have here the option to see this. So,
Diogo, sorry
yes?
for interrupting you. I just saw that for some people with small screens, they cannot see it properly. If you can just zoom.
Here I'm just showing this. I can show you, but I mean, I don't know what I can do besides this.
Yeah, just on the browser with Apple.
Okay. Like this? Is it better?
For me, it's okay.
Yes, okay, I hope it's better a bit more. Sorry.
Yes, I think it's better, no?
Okay. You can do it again. Okay.
Like this? Okay, but I'm about to finish. So okay, so sorry for this. If you want, of course, you can contact us and we will help you a bit more. But as I said, okay, now I have the interactive content here. But imagine that I want to edit this notebook. What can I do? What I can do is that you can clone this to your own file system, to EOS, and we only allow this because, as you saw before, or as I said before, in Jupyter you cannot have the notebook open in more than one place at the same time. So if you try to open it, this will fail. It will complain that some other user has changed the file, and basically this means that you create a conflict. So you can clone and this will create a copy of the project. And now this is basically your own project. It's really a copy. It's separate from the other. So if the other edits something, you won't have this change. So this is a limitation. We are aware. We are trying to solve this. So hopefully this year we'll have some update on this. But for now, you can only do this. Then let me continue showing you what we have here in the top bar. For example, I mentioned that, okay, in projects, you can only see your projects, but if you want to see all of your files, you have the CERN file, and I have here all my files. If you want to have a terminal, you can click in that terminal button, which is here, the first one on the top right. And this opens a terminal, and I can do whatever you do on a terminal. And this is a CC7 system, so you have you know how to use it already. This button here is to see the galleries. Enric will explain to you what these are, but this is basically a way for you to see examples on how to use the service. There's the help button that shows you the help panel, as I showed before. Here there is the running processes, so you can see all the notebooks and terminals that are running, and you can even shut them down from here. So if you are running out of resources, you might want to click here to free some of them. Then there's this button to configure the NBA extensions. So basically in the LCG releases, we have a lot of extensions that are installed there, and you can see them. If you tick this button here, you can click on them to see what they are, and you can tick them to enable. For example, this RISE extension, this is very interesting, and I will show you what it does. Let me show you this. Basically, this opens a presentation. So allows you to do a presentation from your notebook. And the cool thing is that you can even run cells directly here. So imagine having some formulas or plots that are done automatically with some code. You can have them here, and then you can be presenting from your notebook. So it's a very interesting extension. Let me back to the menu. There are two things that I want to distinguish here. This button here on the top right corner, the button most on the right, this is to log out. Logging out from SWAN doesn't kill your session. Your session is only killed after 6 hours after you stopped using the interface, the UI. So you can log out, go to a different computer, and continue with the work where you left it off. But if you, for example, want to, if something crashed, if you want to completely start from fresh, or if you want to change to a different LCG stack or to a different Spark cluster, you can click here, and this will kill your container, it will kill your session, and now you'll be able to return back to this menu. Let me get back to my presentation. I'm really about to finish because I'm already going after my time. There are here some examples of extensions. For example, one to create exercises where you can hide the solutions for your students. One to help you convert Python 2 to Python 3 inside the cells. One to log how much it takes to run a cell. If you have a very long document, for example, you might want to use table of contents because it will allow you to click on the titles and to jump between the notebook quickly. And also the scratch pad, which is basically a separate cell where you can run your code to try different things without having to mess up with your notebook. And the last thing I'm going to mention is that, of course, if you use Jupyter, you probably know that there is Jupyter Lab, which is the next version of the UI. The version 3 has been released very recently. Up until now, the Jupyter Lab has been stable for being used by the users, but not being stable for people developing extensions for it. And we have a lot of integrations in SWAN, and so we are working on porting them back to Jupyter Lab. So hopefully with this new version, it will be a bit more stable and we can have a final product, and we hope to have news by the end of, during this year, basically. So having said this, I will pass my screen to my colleague Prasanth, and he will continue from now on. Thank you. You are muted, Prasanth. And you're not showing the screen.
There is a problem. Can you see my screen now?
Yes.
Okay, thank you. Thanks, Diego. My name is Prasanth Kothuri. I'm part of the SWAN team as well as the IT department. So Diego has shown how you can use notebooks. In most cases, the compute resources that we provide in the notebooks themselves are enough. However, there are cases where you would like to offload your computation to an external cluster with much more memory and CPU cores. Or you want to access data from external file systems like HDFS in the Hadoop ecosystem. And I will also show you how you can access accelerators from SWAN notebooks, in this case, GPUs. Spark is a distributed parallel processing compute framework, which has expressive APIs in several languages. What concerns for us now here in SWAN is Spark also has an API in Python, which is PySpark, and which is available on SWAN. This allows for sophisticated analysis, stream computation, and machine learning on large datasets. You can, however, also use for smaller and medium datasets. Spark has a core engine that takes care of data representation, processing, and graph. And it has specific libraries for different use cases for stream computation or machine learning, or if you're comfortable with writing SQL. Since I mentioned that Spark is a distributed parallel processing framework, so you need a cluster manager that can make these resources across a bunch of machines as a single entity. So in SWAN, we have access to two such cluster managers, which are YARN and Kubernetes. So you can expand the SWAN architecture, what you have seen above, like this when you include a Spark. So you connect as before to SWAN, and in the configuration menu, you have to choose a Spark cluster. In the next slide, I will show you different Spark clusters we have and what is the purpose of each of them. And once you select the Spark cluster in the configuration menu, you land on one of the SWAN machines inside a Docker container with access to CERN resources like CERN Vox, CVMFS, and EOS, experiment EOS instances. And here we have, when you use Spark, you have several actors. So you have a master, which is called a driver in Spark terminology, and you have a bunch of workers, which are called executors in Spark terminology. So the master lives in your notebook. However, it doesn't use much of compute resources. It is only coordinating work among workers. So all the heavy lifting is done on your Spark workers or executors. These are the Spark clusters that are today available using the SWAN interface. So we have primarily 3 clusters. The first one is analytics. It is a general purpose cluster that is available for all CERN compute accounts. However, you have to specifically request access to this if you already don't have it. Here, as you can see, you could have access to a lot more cores. Once we receive your request, typically we have certain rules to give you a quota of up to 64 cores per each user. However, for specific use cases, we could consider giving you a bit more. Next, we have NXCults cluster. So this is a cluster that is used by Beam's department for accelerator logging project. So all the data from the sensors of the LHC machine is going to a middleware layer and eventually coming to a Hadoop cluster. And this Hadoop Spark cluster can be accessed from SWAN interface as well. And the access to this cluster is controlled by the project team. And we have a third cluster that's called cloud containers. So this is a compute only cluster. So that means this cluster only has CPU and memory. And the storage comes from external file systems like EOS. So we have EOS mounted onto these containers or nodes, experimental EOS instances, and then you can access data. And as you can see in the picture, so you can, while configuring your SWAN session, you have to select one of the Spark clusters from the drop-down menu. Using any of these distributed parallel frameworks comes with certain complexity. Spark is relatively easy compared to other ones, but still, since you have multiple actors on several machines, so you have to take certain actions to equalize the environment across these actors. For example, equalizing your Python path or Java class path or native library path. So for this, we have developed certain utilities. So one such utility is called Spark Connector. So this takes away the configuration complexity of setting up your Spark application or Spark session. So within the notebook, so you will see a star button. Once you click on the star button, you have a side panel coming up where you can simply connect without specifying additional configuration. This is most of the time good for the beginner users. So you are returned with what is called a Spark session object, which will become an entry point for your analysis with Spark. For certain communities or projects, we also bundle configurations because in some cases you have a lot of options to specify and it is not feasible for each user to specify. So we bundle them. So you choose a bundle and you connect and your actors have all this configuration. And for power users or somebody who is advanced with Spark, you could also specify your own configuration options. And the second utility that we have developed is called Spark Monitor. So it is a Jupyter Notebook extension, like what Diogo showed in the previous slides. When you offload a computation to a cluster, so instead of trying to show a busy screen and eventually getting a result back or error message, we thought we would show the live monitoring of the Spark computation that is offloaded to this cluster. So as you can see in this graphic, you can see the live progress of your job, the amount of resources that you can consume. So in this case, I'm going up to 72 cores as I see now, and the elapsed time. We also show you a graph where you can see the number of cores that you have asked and active tasks. So these are the number of parallel tasks that are being executed across a timeline. We also show you what are called jobs, stages, and tasks. So this is a Spark terminology. So a Spark application is decomposed into jobs, stages, and tasks. Tomorrow we have a bit more like a 15-minute training on Spark. So where I explain in more detail. But for today, it's good enough to know that you can see all this information on a timeline. The third utility that we have is what is called a HDFS browser. So from within the notebook, we have an icon. This is the elephant symbol. When you click on it, you can browse the HDFS file system. And this acts, this is a useful tool for selecting your directory or your data set as a start for doing your analysis. This is only read-only. You cannot do any actions. You can only perform actions on the data you own. So the ACLs work as we expect. So I have a little video that I have made. So this is how the Spark session is established. So usually there is a setup time of 15 to 20 seconds. to set up Spark is in the background based on Scala and JVM to set up all the JVMs across all these machines. And once this is done, you are returned with a Spark session object, which acts as an entry point for the analysis. Now I switch to the GPUs for SWAN. So in addition to offloading compute to the external clusters, so recently we are also offering accelerators from the notebook. So for example, today we provide GPUs within a SWAN environment. So this is available on a pilot instance of SWAN on Kubernetes. So together with changing the backend architecture of SWAN from physical machines to containerized Kubernetes architecture, we are also providing additional features like GPUs. So these are available at a different URL, not the one that Diogo showed. It's a swan-k8s. It will become the default instance at some point in future. Today, we don't have many, but however, we have around 5 GPUs that have been actively used by users since a few months. More are being added. So more are being added in 2 ways. So one for generic usage, another one for certain projects. So if we are in the process of adding certain amount of GPUs for the Open Lab project and providing access to the Open Lab users through SWAN interface. So when you want to use these accelerators, you also need CUDA software that comes from NVIDIA. So thanks to our colleagues from EPSFT, so we also have the latest versions of TensorFlow and PyTorch available in this tag that's called 99 CUDA 10.1. You also have the previous versions available in the older releases. So since we only have a limited set of resources here, and so far, I don't know whether we have not advertised enough or there is not much demand. So we only had up to 4 or 5 concurrent users. We had no problem on sharing this. So in case we have more users than the GPUs available, each user gets 1 GPU and 2 CPU cores and 16 GB of RAM. And we also terminate after 6 hours of inactivity. So when you choose these options from the configuration menu, if they are available, you will land in a Docker container having access to these resources. But if we are out of these resources, we'll show a message at the moment saying that please try again. And I have a short video of how you can access this. So you have to select a software stack, either the bleeding edge CUDA stack or one of the stable releases, and you start your session. And you will see your projects. So you click on the notebook and you can run all cells. So there are a couple of snippets to see what version of TensorFlow you have and whether you managed to get a GPU attached to this particular notebook. And then this is a simple example of running MNIST. So this is a classifier to identify handwritten digits. And you will see in a minute that from the terminal, so you can also monitor the usage of the GPU that is attached with some of the NVIDIA tools that we have. Okay, so we have an initiative that's called Science Box. Which is essentially a packaged deployment of a bunch of CERN software. That is SWAN, which is the Jupyter Notebook Service, and Sunbox, which is the layer on top of EOS storage, and EOS and CVMFS. So all these are packaged, and we have a couple of deployment models. How it's mainly meant for the external sites, so they can either deploy today on Docker Compose or on Kubernetes. So this was created as part of a EU-funded project called Up to You. As the SWAN is being updated, so there is also a new version of ScienceBox that is in the works, that is much more modular and much more configurable. There have been a lot of successful installations in the high energy physics community, especially in the RNet and SARA sites. And we see interest from other institutions from time to time. Yeah, I now hand over to Enric, so we take questions towards the end.
All right, thank you, Prasanth. I'll share my screen now. Can you see my slides?
Yes, I can.
Okay. Right, so now let's talk about how to get started with SWAN. So if you are a new user to SWAN and you are not familiar with the features we just described, or maybe you are not even familiar with the Jupyter Notebook interface, it's usually helpful to start from some content that someone else created. And in that sense, you can basically share content with others in SWAN in 3 different ways. The first one is what Diogo explained about the sharing feature of CERN that you can access in SWAN. So you have your project with your notebooks and you say, I want to share this project with these people, and then they see it in SWAN as well. That's one option. Another option is if you are preparing a training or a course, you can create a repository on GitHub, for instance, with some notebooks, and then you share with your attendees these kind of open in SWAN links, so that just with a click, the content of that repo with the notebooks is copied into their CERN box, and they can start the training right away. But then there's a third option, which is the galleries. So in SWAN, we have these galleries, which are just groups of notebooks. You can access them with this icon, as Diogo explained, or you can also go to this, actually this website, I can show you, where you find groups of notebooks on different topics, right? And they are all presented this way. So you have the notebooks with some screenshot that shows the content of the notebook, and you can go and click on one that you're interested in. And first it shows like this. It shows as a static HTML page. You cannot do anything with it. You can just read it. But maybe, well, you can also download it if you want to your local machine. But if you want to work with it, you can go here and you say open in SWAN. So I will just start my session with the default parameters. And what SWAN will do is it will take that notebook that you clicked on, that you selected, and now it's doing it. It will download it into your CERN box, and it will open it for you, so that you can interact with it. Okay, now it's alive, and now you can run the cells, type new code, whatever you want. Okay, so that's the idea of these galleries. So let me go back to the slides. So if you are interested in adding a new gallery because maybe you think you have some content that is worth sharing with a community of users, please let us know. Here you have some instructions. You have a link to some instructions on how to create a new gallery in the SWAN gallery website. Right, so this concludes this section of our training today about the features of the service, and now we are going to introduce what we're going to talk about tomorrow, which is use cases of SWAN. So we're going to see how SWAN is used for what purposes, at least the ones that we know. If, of course, you see that you are using SWAN for something else that we don't explain today here, please let us know, because we're interested in knowing new use cases. But these are the use cases that we gathered at a workshop that we organized with our users. We had a full day of presentations, and they just told us what they use SWAN for. So we're going to give you an overview, just in case some of these use cases can be useful for you. So first, SWAN is being used for physics analysis. Since you have the notebooks, you can do interactive physics analysis from the notebook interface. It's usually not big analysis, right? It's small, medium size. You read some input data that it's some gigabytes, perhaps, in simpler formats like in tuples, for instance, right? So not heavyweight analysis. And you can access your data. It can be on CERN on your user space, or it can be also on other parts of EOS. Maybe you have some project shared with other people on EOS that you can access with your credentials from SWAN. And it's also possible if the data is in some EOS experiment repository, like EOS Atlas, EOS CMS. All of those are mounted in SWAN as well, and you can access them from SWAN. And for software, well, for software, as Diogo explained, you can configure your environment with the LCG releases. This means that you have like 500 packages at your disposal, and many of them, you can use them from analysis, like for instance, root, of course, and then there's also Python data science libraries, NumPy, Pandas, and whatnot. Machine learning libraries, of course. You even have an R kernel if you want. So you have plenty of options to pick. And this is an example of a user that we had at the workshop that was reading some root files, creating histograms, and plotting them on the notebook on SWAN for his physics analysis. But you can also do other types of analysis because, of course, SWAN is generic enough to accommodate other types. For the data, I mentioned you can have data on EOS, but not only. You can also have data in some other sources. Like we have users that read databases from SWAN, external databases that they read remotely from SWAN, or Prasanth mentioned HDFS also as some source of data you can use, right? And then for software, it's the same software I just described for physics analysis. You can use it also for other types of analysis. And we had one such presentation at the workshop of a user from the Beams department that is using this Python library, PyTimber, to access a database of logging data of the LHC. So they store some measurements, some parameters, and then they use this library to query them and plot them in the notebooks from SWAN. Interactive visualization and monitoring. So notebooks are an interactive interface, so they are a good candidate for working with interactive graphics, with libraries like Matplotlib, Seaborn, and others. And with respect to monitoring, we think SWAN can be a complement to monitoring. I would say SWAN is not intended to be a platform for live monitoring because you usually don't have a long-running process in SWAN all the time, day and night running there, doing the monitoring, right? So, but you can use it as a complement to it, like these people were doing in the Atlas trigger and data acquisition system of Atlas. And what they were doing actually is they have their own monitoring tools, like, I don't know, Grafana, for instance. And then when they spot something in these tools, some error, some failure, or something they want to explore further, then they go to SWAN and they load some data they have in a database and they explore, they find out what's going on, right? So it can be a complement to monitoring, but it doesn't replace it. Entry point to computational resources. We've seen this with Prasanth a little bit. So notebooks are meant for interactive computing. So you usually do lightweight computations in them. You don't type code in a cell and wait for hours to finish. And also the SWAN session that you get has limited resources. You get some CPU, some memory, and you're not intended to run their heavy computations, right? But you can still run them somewhere else. So you can connect from SWAN to external computational resources. For instance, examples. We have users that connect to the grid from SWAN to submit jobs. We saw the example of Spark clusters provided by SWAN. We saw GPUs, you can attach GPUs to your session. We are also discussing the integration now of HPC clusters at CERN from SWAN. So you have plenty of options. And this is just an example of an analysis user that was generating his credentials in SWAN for submitting jobs to the grid, then waiting for the results. When they were ready, he was post-processing those results in SWAN on the notebook. And finally, since we are going a bit late, we're running late. So education and open data. So education for me is one of the most important use cases of SWAN. You can think of notebooks as teaching material, right? You can prepare exercises in the form of notebooks because you have everything there. You have the code, you have text with the explanations, you can run it interactively. So it's useful for that. And in SWAN, we have hosted through the years many courses. I myself, I teach root to the summer students, for instance, and I use SWAN. But we have had like machine learning trainings, CERN School of Computing exercises done with SWAN, Spark, big data trainings, so and many others. The idea here is that it's easier for the organizer, right? Because you have your teaching material in a repo. You share some link with the attendees, click here, and it will open in SWAN, and then they don't need to install anything. You don't need to worry about them coming with laptops with different configurations, different versions of the libraries, and so on. They just need a browser. They open it in SWAN, the material, and they have the software already there on CDMFS. Then for open data, we had a presentation in the SWAN workshop about a user analyzing open data, in this case, CMS open data from SWAN. Here it's important to mention something that already Diogo discussed, that the central instance of SWAN is protected by CERN username and password, right? So the resources are reserved for CERN users. But you can also install your own instance of SWAN using ScienceBox. So ScienceBox is like an installable version of SWAN, so that you can have your own instance and then you can open it to anyone that you want, right? So that's a possibility. Right, and this concludes what we wanted to say today. Just a few final remarks. How to get help. There's this SWAN community forum. If you have some questions, any kind of question, just go there, please, and ask. If you have some troubles with your session, some failure, you can also open a ticket on ServiceNow and we'll respond. And there's the help panel on SWAN that you can use for get help on various features of the tool. Finally, some links and addresses, like for instance, the one of ScienceBox. If you're interested, you can click there and get more info. Thank you for your attention.
Thanks a lot, Enric, Diogo, and Prasanth. Very nice presentations. So even that we are a bit late, I would like that we read some of the questions. So first one from Rob: could one add other languages, in particular Julia, to the environment?
Yeah, so maybe I can answer that. So the service itself, SWAN itself right now doesn't provide a feature to add new kernels. I shared in the chat a recipe from a user. So this was contributed by a user, where he explained how you can actually do that. You can add new kernels to your session. So maybe you can use that for now, but in the new design that we are doing of our interface to have it based on JupyterLab, one thing that we want to introduce is for the user to be able to create projects and then link environments to projects. So you will be able to actually have one project where you will be able to add your kernels as well, right? And any other package that you want for that project. So that's in the plans.
Okay, thanks. So although I think you were already replying, but Felipe says, Diogo, do you have an environment tutorial and new kernels with the environment?
I don't fully understand the question, sorry. What does it mean, environment tutorial? I don't know if maybe Felipe can say something.
I think Felipe is around.
Felipe. He is, but he's not. He's unmuted but not speaking.
Maybe he meant the same as these other.
Yeah, probably. So yes, so Enric already replied, and also on top of that, all of our software comes from CVMFS. So if you really think that there's a very big community of users for some package, and this also includes kernels, if there's a very big community of users that might benefit from it, we can propose it to the librarians to see if it's okay to add this or not. Depends on the maintainability, of course. So.
Okay, then another question that I think you were replying, but I think is good that all the audience heard your answers. So how do you, from Konstantinos, how do you prune inactive pods? How do you detect inactivity? How you prune?
So basically, Jupyter Hub has control all of this. It checks whether the interface is being used by someone, and it queries Jupyter, which is running inside your container, to know if there's something running. So after there is nothing there, so if you close your window, for example, and nothing is running, the time starts ticking, and after 6 hours, we remove this. Jupyter Hub tells us.
Okay, thanks. And a topic that I think was a hot topic in the chat. Are you considering Dask cluster support for the future?
I can take this maybe. So SWAN doesn't have unlimited resources. So currently we have resources to provide users notebook sessions. However, we have got these questions in the past, and we already are in the process of developing, let's say, a tool or an extension that allows you to attach your own, let's say, external resources. Today, as already pointed out in the POC, we have an extension that allows you to attach your Kubernetes clusters to the notebook, to the SWAN notebook. So with this, you can easily offload your computation to a Dask that is running on Kubernetes. I think we still need to deeply discuss internally. I think this is the model that we might go ahead. Because as you can imagine, resources, compute resources at CERN are already divided across experiments and user communities. We are not an arbiter of these resources.
Okay, so then from Konstantinos, do you have a detailed architecture diagram of your Kubernetes deployment? I would like to understand how you implement user management, authentication, authorization, and multi-tenancy.
Maybe I can reply to this. So the latest Kubernetes deployment is based, the one that we have in this one, kubernetes.cern.ch. It's based on 0 to Jupyter Hub, but we have all of our own components, for example, because Jupyter Hub is very modular. So you can create, for example, the authenticators to authenticate against the CERN SSO and some other tools that we can instantiate with Jupyter Hub to manage this. A good place to start would be maybe to look at our GitHub repo, and there you see all the components that we developed. If we didn't develop them, they will come by default from Jupyter Hub.
Then from Erika, thanks for the nice presentations. Can you tell us more about the plan of extending SWAN to be collaborative, 2 or more people working on the same notebook?
So we are working on a European project in the storage group, and we are thinking about introducing a functionality that is similar to what we have, for example, in CERNbox when you open a Word document or a PowerPoint document, and so basically what happens is that we lock the file. So we will allow you to have editing capabilities, but we might not allow you to edit at the same time. So this way you don't interfere with the work that the others are doing, but you still have the possibility to edit at a different time. But this is still being worked on. We still need to see what is possible and what is not.
Yes, and if I may add, on this, we are also looking at what the Jupyter team is doing, right? Because this could also be supported natively by Jupyter. As far as we know, they have been working on this for quite a bit of time already, but they have not come up with a solution yet. So the day Jupyter supports this natively, we will have it automatically in SWAN as well. I mean, it's not trivial, right? Because you need to decide on how you lock. Are you locking by cell? How do you do the exchange of data between the users that are collaborating in the same notebook, right? So this is technically not trivial, and yeah, but we have an eye on it. Yeah.
Okay, so also from Philip James, attach your own computing is really interesting model. Would love to learn more. Any links? I think maybe it will be interesting that you provide a useful list of links. So then, because I could see that you were sharing links even here. So I don't know, but okay. This is from my point of view.
Yes.
I would say a very good place, put this question in the SWAN community, and we can discuss it there as well. Because some of these things that we developed, these were part of Google Summer of Code, for example. This was some projects that we done with the students. We can link them to the presentations that they give, and we'll give you an idea of what has been developed.
Okay, there are a lot of questions. I would like, okay, let's see if we can, let's wait. If it's okay to reply until 12:30.
We have time. We have
okay,
time.
for
Yeah,
you it's
for us,
okay until 12:30. Okay,
Yeah.
so let's try to resolve all the questions. So from Rasmus, can you maybe repeat the current plans for rolling out Jupyter Lab, and what are the possibilities for using something a bit more ID-like than a notebook?
So plans for Jupyter Lab, we've been trying we are working, and we already have some work done in the migration of these extensions and integrations that we've done to Jupyter Lab. But this is a completely new platform, so it has not been easy. And as I said, the platform itself has not been stable enough for the developers that are developing extensions. We hope that during this year, we will have the thing available. There is also a couple of bugs in Jupyter Lab itself that prevents our use cases, because right now we could already expose Jupyter Lab in some kind of form without these integrations, but things do not work exactly as they should because of some bugs on Jupyter Lab. So we don't have a date to announce, but we are working on it, and it should come this year.
Yeah, and for the ID like extension, I think actually Jupyter Lab, since it supports anything as an extension, there would be room for extending our interface, not just notebooks, but also any other thing that can be an extension in Jupyter Lab. And IDEs can be one of these things, right? So you could have all the other windows in that interface that is not only notebooks.
This is still something that we need to discuss, if you how easy it is to maintain and if it's possible, because there are things like there's a version of Visual Studio Code that runs on the web browser, so maybe this could be provided or users could install them themselves. So this is still to be seen, but for now the priority is really Jupyter Lab and to make that work.
Okay, from Carlo, thank you for the presentation. Will SWAN ever support Anaconda, EMS, or protocols in general?
This is Anaconda is something that we also did a project in Google Summer of Code, and there have been some developments on the EOS side that allows us to push this to production, but there's still a lot of work to be done on this, and this is also part of this revamping of the software integration that Enric mentioned before. So this is something that we are considering for the future, but again, we have our priorities, and for now it's deploying Jupyter Lab, have this working properly, and then start adding new features.
Yeah, the idea would be, it's not done yet, right? But the idea would be that you have your project, and your project is tied to an environment, and that environment can be an LCG release, as we do now for your sessions, or it can be an Anaconda environment, right, with the packages that you want. Or maybe I can also mention this. It could be also experiment software stacks like CMSSW, right? Because we've had cases of users that try to combine the environment coming from the LCG release with the environment coming from the CMSSW stack, and that gives conflicts because there are packages that are duplicated in both stacks and so on, right? So having this option of just tie your project to a particular environment, not necessarily an LCG release, is something that, yeah, we want to go for.
Okay. So from Alessio, thanks for the presentation. One question, is there a limit on the time allocated for each cell to run on the notebook? Is there a way to modify it?
Yeah, there's no limitation on cell running time, but we can say our recommendation. So best practices on how to use the platform. In principle, you shouldn't have long running processes, as I mentioned before in SWAN, right? It's intended to be more interactive. If you need something that runs for a lot of time, you have options to offload that computation somewhere else.
And another aspect on this is that if you're running a long cell that puts the output somewhere in the storage, fine, that would work. But for example, if you expect the output to return back to the notebook, the way that Jupyter works is that the output only appears inside the notebook if it manages to receive in your browser the output. So imagine that, for example, you have a long-running cell and you close the window, and then you open again, or you close the lid of your laptop or something like this. All of these outputs will be lost because you didn't have an open window ready to receive the outputs.
Okay. Also let you know that many people is giving you the thanks for answering all the questions and for the presentation. But okay, the next one from Konstantinos. Do you offer workflow pipelines functionality integrated with the Jupyter notebooks?
I can take this. No, our plate is already quite full for this year, but we would consider in future. Some of our users want to use such functionality. We have done a prototype around Airflow. So if you want, we can share some more details on this. So basically, you develop your Jupyter notebook in SWAN and take this to the Airflow and do the pipelines there.
And from Sveto, do you support multiple sign-ons? That is CERN sign-on plus a local sign-on.
In production, we only support CERN SSO. If you are using ScienceBox, this is Jupyter Hub that we are putting there with some extra of our components on top. So Jupyter allows you to switch different authenticators to authenticate against different services. So this would be a possibility. And you can do it already with ScienceBox, but as Prasanth mentioned, we are working on a new, more modular and easier to configure version of the ScienceBox. So this will be easier in the future.
The question was more like, can you have them at the same time? Can I have CERN users and local users who are not registered at CERN, obviously? Not switching between, but offering both at the same time.
Again, for production, no. For ScienceBox, I don't think, for that, of course, you could develop, but you would have to develop your own authenticator on Jupyter Hub and try to inherit from two different types of authenticators, one local authenticator and one for OAuth as OIDC or something. But as far as I know, there is no authenticator that already gives you this possibility. You would have to develop yourself.
Okay, thanks.
And then the last one from Konstantinos again. Are there any provisions for serving machine learning models to process data streams in production?
Yeah, I don't know if this means with Spark. Maybe
could be with Spark or with any workflow engine. I mean, I'm not sure what the implementation would be, but in general, if the principle in terms of the design is there.
Yeah, I don't know, Prasanth, you want to comment on this?
I mean, you're asking for a model serving service. I would say that would be a little bit outside on the notebooks. So there could be a service that is offering you model serving, but it won't be part of SWAN or notebooks.
Okay, exactly that was my question, if this is part of your design or not. Thank you very much and for answering all my questions.
Yeah.
Thank you for the questions.
So yeah, thank you very much. Also, we receive a thank you from Enric Granger. So yeah, thank you very much for the speakers and also for the participants. I think it was very useful and productive. And yeah, see you tomorrow. No, yes, tomorrow at the same time at 11.
Yes.
See you tomorrow. Bye-bye.
See you tomorrow. Bye-bye.
Bye-bye. Thank you.